Okay, we're going to look at the pre-responsive questions for Chapter 5. Any of these questions is a possibility for your incapacity. At the 2010 question number 1, it says, there is no snow on Janet's driveway when snow begins to fall at midnight. From midnight to 9 a.m., snow accumulates on the driveway at the rate modeled by F of t equals 7t cosine t cubic feet per hour. Janet starts removing snow at 6 a.m., so time 6. The rate g of t in cubic feet per hour, which Janet removes snow from the driveway at time t, is modeled by g of t equals the piecewise function. Question A says, how many cubic feet of snow have accumulated on the driveway by 6 a.m.? All right, so basically that's a summation that you're trying to find. You're trying to find from 0 to 6 hours. So you can't just plug in 0 hours and plug in 1 hour, 2 hours, and so on, add them together, because the snow is accumulating every single second. So you need an integral. You need to integrate from 0 to 6 hours of f of t dt. Now, on the AP exam, I would probably write it like that, because you get a point just for writing that integration right there. Now, if you write it like this, 0 to 6, 7t e to the cosine t dt. But let's say you had forgotten the t, you hit that point wrong because you copied the f of t wrong. So be very careful. So I'd always write this part first, just so you get that point. All right. So since this is a calculator question, you can just plug this into your calculator, which is a good thing to do. We haven't learned how to integrate by parts yet, so we wouldn't know how to integrate this quite yet. So when you plug it in, you're going to use fn int, so finite integration. You're going to plug in 7t e to the cosine t. You're going to go long x for this. You write it x's. X e to the cosine x. You're going to integrate from x, goes from 0 to 6. So you'll fit it in just like that. When you do that, you get 142.274 or 75. All right. Now, if I was going to do this problem, since it's a calculator problem, I would probably put that f of t function in for y1, and I probably would have done fn int. So that would be math 9, and I'd do y1. And you can find y1 on your calculator by doing variables, so VARS, arrowing over to y variables, function 1, so select 1, and then y1. All right, part B. Part B says find the rate of change of the volume of snow in the driveway at 8 a.m. All right. So when I hear rate of change, it kind of makes me think of slope. Rate of change is going to be something like cubic feet per hour. So that's what F of t was in. It was in cubic feet per hour. And g of t was also in cubic feet per hour. So if I'm trying to find the amount of snow on the driveway, it's how much you had at, well, how much accumulated after 8 hours, so F of 8. And then you subtract out how much she got rid of after 8 hours. So that's G of 8. Okay. So you find that F of 8. I'm just plugging it in. Again, this would be really easy if you had this in for y1. G of 8, that's your 108. So when you put this into your calculator, you get negative 59.582. Or you could say 59.583. Make sure you put your units. You don't actually get a point on this particular question for having units, but a lot of times you do get points for units. These are both in cubic feet per hour, so it's cubic feet per hour. Okay, see, let h of t represent the total amount of snow in cubic feet that Janet has removed from the driveway at t hours after midnight. express h as a piecewise function with domain between 0 and 9. Okay, this one's kind of tricky. I think the best way to think about it is breaking it up into pieces. So between 0 and 6 hours, that's right here. Between 0 and 6 hours, so midnight and 6 a.m., Janet doesn't remove any snow. So the amount that is there at that time is just whatever f of t is. So set it up. Go ahead and leave it at less than 6 just because that's the way it was in g of t. It doesn't really matter. Okay, so that's just going to be whatever f of t. Oh, and then reading this wrong. See now that she has removed from the driveway, so she hasn't removed any. So it's just going to be 0. Right after that, so between 6 and 7 hours, that means she's done 1 hour of work at exactly 7 hours. But for any time between that, like 6.5, if she had only worked for half an hour, she would only remove 125 times 0.5. So it's kind of tricky. You need to think about how this is related to the between the 6 and 7 hours. So if, let's see, time was 6.8, then she would have worked 0.8 hours. So best way to write this is 125, and it's going to be whatever t is minus 6. So like I said, if she worked 6.8, you do 6.8 minus 6 for those 6 hours she did work before. 125 times 2 minus 6. All right, same thing for the next thing. So if t is between 7 and 9, that means for the first 6 hours she did nothing. Between 6 and 7 hours, so for 1 full hour, she had 125 cubic feet. And then after that, so between 7 and 9 hours, she's going at a rate of 108. So it's 108, and then you have to do the same kind of thing. So whatever t is, you can subtract out 7 hours. Because for the first 7 hours, she went 0 for the first 6, and then 125 cubic feet per hour for the next one. Okay, so 125 plus 108 times 2 minus 7. You can just read it like that. You don't need to think about it. Okay, and that one time is between 7 and 9. All right, so that's what H of T is. Part 2. How many cubic feet of snow are on the driveway at 9 a.m.? All right, so the snow has been accumulating at a rate of f of t, which is right here. And she's been removing it at the rate of g of t, which is right here. So we can link those two things together. So we're going to say between 0 and 9 hours, right, and I say f of t dt, that's going to be how much snow accumulated during that whole time. So then you subtract out how much she removed. Well, how much she removed is what you found in C. So that'd be H of 9. Okay, so we can find those two things. So you can integrate to find between 0 and 9. You can go ahead and do that now. Okay, so the first number was 367.3346. And then H of 9 is just 125 plus 108 times 2. So that's 341. So when I do the first thing minus the second one, we get 26.335 cubic feet per. You also have to put cubic feet. No, sorry, not cubic feet per hour. Cubic feet. We're talking about the amount of snow that is accumulated. Now, what I always like to think of is what the graph looks like. You know, if you have some function f of t, and you're integrating from 0 to 9. F of t is in cubic feet per hour. And this was in hours. So the area of a rectangle right here would be, the height would be cubic feet per hour, but the width would be hours. So that's how you end up with cubic feet. All right, so let's talk about the points on this problem. Okay, so on part A, you get 1 point for your integral, 1 point for the answer. On part B, you just get 1 point for the answer. In part C, you get 1 point for each part of your piecewise function. So even if you knew that she just picked up 0 between 0 and 6 a.m. or between midnight and 6 a.m., you get a point for that. So at least write a little bit, a little bit. And then D, you get 1 point for the integral. 1 point for seeing that you need to subtract out h and 9, and 1 point for your answer. So those are the 9 points for that question.